explain the question number 8 of the project. This is equation of motion in direction y. This is the variables. Initial velocity equals to 0, acceleration equals to minus 32.2 feet over second square, and height equals to 100 feet. This is a picture that represents the problem. This is Mark, this is Tom, this is height, and this is the formula that we can use of this problem. And this is initial velocity plus 1/2 at squared plus height, and we solved it. 1/2 times minus 32.2 t squared plus 10 plus 100, sorry, and this is the result because you multiply this times this, and this is the result of this multiplication.
The question B says, calculate the derivative using the limit definition of the equation of motion in y direction. Okay, it says limit, we use the limit equation of motion. F of x is going to be the equation of motion. So we substitute the values, here is the values, and this one because it's f of x. Okay. Then we multiply this to the square, and this is the answer. Okay, the next step, we are going to eliminate we are going to simplify this. Okay, we eliminate this with this one, and 100 with 100. Okay, and we to the next step. This is going to be, but we have h and h, and this that is the same. So the only answer that we have is minus 32.2 time. So this is the answer here. And velocity of time is equal to minus 32.2 time.
Hi, I'm going to explain you how to find the time to reach the ground. And first, we need to equal the function that we found in the first exercise to 0. Then we need to clear the t, but it's in the square, and we have to take out the square. So we put a root, and the squares go away. And then we solve this root, and the answer is 2.5 seconds.
Well, I explained the impact velocity in y. The formula is velocity and time. Velocity multiply the time, and velocity is equals minus 32.5 times 2.5. I substitute these values, and the result is minus 80.5 feet over seconds.
So good to be there. Getting what I want, boy. What does that make you?
The letter E is, how much distance does Mark have to run to catch the ball? Okay, first we have to use this formula that is velocity multiplies time. And then we substitute the values, that is 50, and then multiplies 2.5. And the answer is 125 feet. But Tom is 50 feet away from the building, so we subtract 125 minus 50, and the answer is 75 feet. So he runs 75 feet.
Are you gonna stay the night? Are you gonna stay the night?
The question F says, calculate at a time of 2 seconds the position and velocity of the ball. Okay. First we divide in y-axis and x-axis. The height is the position and the velocity. Okay. We put the same equation that we use in all the problems, but substituting t for 2 seconds here. And we solve this, and the height is 35.6 feet. Then the velocity that we have is minus 32.2 plus time. We substitute t for 2 seconds and is minus 64.4 feet over seconds. And then in the x-axis, the distance is initial velocity plus time. We substitute time plus 2 and is 100 feet. Here is on the drawing. Is the position, the height is 35.6 feet. The velocity is the same, is 50 feet over second. But here is minus because it's go down. So it's minus 64.4 feet over seconds. It's minus because it's down. And the distance is 100 feet.
There was a time I used to look into my father's eyes in a